All right. Hi, everyone. Good morning. This talk is about how to achieve more with AI. And I know there's a big hype on AI right now. I'll try to talk about what we can do with it today, as opposed to like what we'll be able to do in the next few years. There's a lot that you can achieve today, and I'll try to show you some concrete examples, as well as what are the limitations of these systems. So the talk is called How to Achieve More with AI. It's about productivity, and the framework here is how to adopt AI, extend AI systems, and then build your own copilot and agents. Before I get started, I wanted to know a little bit more about you in the audience. So who here is a developer? All right, so a good 30% maybe. And who is more on the decision maker, business user side of the house? Okay, great. So this talk should cater to both audiences. I'm trying to show how you can do more with AI, whether you're a developer or not. So first, a little bit about myself. So I'm Patrick Chanezon. I'm from, as you can hear from my accent, I am from Paris originally. But I live in San Francisco. I've been there for 20 years. I've worked at many companies, from Netscape, AOL, and Sun, Google, VMware. Actually, when I was at VMware, I think there's an office in Sofia here, and I came here to talk about Cloud Foundry probably like 13 years ago, so that's a long time ago. And so what you can see in my resume that I spent my time most of my career competing with Microsoft, and finally a few years ago I joined them to manage the developer relations team here. I spent some time at Docker as well on containers. My whole career has been about developer productivity. That's really what interests me in life. How do you build platforms for developers and make them more productive? And right now is really an exciting time to be a developer. But I think it's an exciting time for non-developers as well. And I'll talk a little bit more about that, like why it's important. But first, I want to talk about what makes us all be here today to learn about technology and AI. And I don't know about what for you triggered you being interested in this field. For me, it's really about dreams from my childhood. When I was 10 to 13-year-old, I used to be very much into science fiction. I think Star Wars came out when I was 10. I remember going to the movie, seeing that with my mother, and there were these robots that were talking. And then I was reading a lot of Asimov back then. Same thing, robots that are talking and reasoning. And I was kind of dreaming of a future with that kind of stuff happening. What is really cool is that it's actually happening right now. So it's really exciting to be a dev nowadays to build these type of systems. So in this talk, I'll talk about the AI wave, like all the stuff that's been happening in AI, how to adopt AI, how to extend AI systems, and how to build your own AI apps. And I'll talk a little bit about trustworthy AI, which is a very important aspect there. So let's talk about the AI wave first. So the AI wave is not new. Artificial intelligence was a discipline that was born in the 50s. Then there was machine learning in the 90s. That's where I came out of school, and I remember I was hesitating to go in that field. And it was the beginning of what was called about the winter of AI, where there was big hopes in the 80s, and then in the 90s kind of a slowdown. Then in 2017, there was the Google Transformer paper, the deep learning movement started, and in the past 2 years, generative AI, and there was really a quantitative leap, a qualitative leap in there that happened with these new systems. The original paper from Google, the Transformer paper, is the type of models that we're talking about. And what happened in the next few years is that with cloud computing and being able to do the training of these models in parallel on many GPUs at the same time, and then sending the weights back into a single system, we were able to build bigger and bigger models with a bigger number of parameters. And what became interesting is that at a certain size, they became to exhibit some really interesting properties to build applications with them. And so that's what OpenAI did with ChatGPT. It came out 2 years ago, one of the fastest systems that's been adopted by people. It runs on Azure, so there's a partnership between OpenAI and Microsoft. It's backed by Cosmos DB. It's developed on GitHub, so there's lots of ties between OpenAI and Microsoft. And at Microsoft, we're actually selling the OpenAI models in something called Azure OpenAI. If you're interested in how ChatGPT and the GPT models are built, there's a really good talk by Andrzej Karpati at the State of GPT at the Build 2023, and you can find the video for that. And I'll share my slides at the end. You'll find all these references in there. But the GPT models are not the only ones. There's a whole lot of different models that are out there. The Cloud model, Sonnet are really good. There's the Gemini model from Google. There are open source models like the one from Meta, Llama, who are like really of excellent quality. And it's, there's lots of innovation in that space. What's interesting, though, is to look at the scaling laws. For the past like 40 years, we were following what is called as Moore's law, where the number of transistors on a chip doubles every 18 months. And so you had this nice linear curve in there on a logarithmic scale, where we had a factor of 1.4x every year. And that lasted for a good 40 years. Now what we're looking at here is the size and number of CPUs and GPUs or flops being put into training models. And we saw an inflection point around 2010 where the curve started getting much steeper. So there's an acceleration there. And that's what you're seeing when you're seeing the news about all the big cloud providers buying lots of GPUs. There's literally thousands of GPUs that are being put into production on a daily basis nowadays. And so there's a lot of build out for that capacity. All that computing capacity helps us create these large models that then we can use to build full systems. And the way the full system looks like right now is that there's this new universal interface that's appearing. So at Microsoft, we do that with Copilot, but it's that chat interface where you're interacting with an AI in a natural way. And here it's not only the chat interface, but it's also, now you can do voice. These models are multimodal. You can talk to them. They can answer you. They can understand images, and now they can start producing videos. In addition to that, you have memory and context. So you ground the models into context, and they keep a memory of the interaction that you have with them. And so there's a lot of work happening in this area. And so if you're a developer and building these type of apps, there's lots of work involved into cleaning up your data, making sure the model has access to the data. And then there's reasoning and planning. Some of the latest models, like GPT-4o or Claude Sonnet 3.5, start to have characteristics where they can write plans. So they don't reason the same way as humans reason, but they still exhibit characteristics that are similar to reasoning. There's a quote I really like by Edgar Dijkstra. He's a computer scientist from the 70s, from Holland, I think. And one of his quotes really resonated a lot with me when talking about these AI systems and when people are trying to anthropomorphizing them and thinking that, hey, the AI is thinking. It's actually not thinking. What Dijkstra used to say is that it's as interesting to ask yourself about whether a computer can think as whether asking the question about whether a submarine can swim. And I think that kind of, it's a good analogy because these systems don't work the same way that we do, but they exhibit some characteristics that are useful for building applications that help us achieve more. The big trend this year, so there's been many trends over the past 2 years and it's moving very fast, but the big trend is to build what are called agents. The first wave of AI was about Copilot, so you interact with a chat bot and you're chatting with the system. It's a synchronous interaction, you're asking things, it's answering you, you tune it and you tweak it. The new wave that's happening right now and the kind of systems and frameworks that people are putting together are around building agents. So these are like systems that are more independent, they can plan interaction over a long time, they can tweak the plans. You still need to interact with them at some point. There needs to be a human in the loop, but they're a little bit more autonomous than the copilots. So you have personal agents, some that are built by organizations, some that focus on specific business processes, and some that will be across organizations. So that's kind of the big trend for this year. The mission at Microsoft is to empower every person and every organization on the planet to achieve more. So we're building this type of systems really with productivity in mind, and that's what my talk will be about. So the systems we build at Microsoft, the way we see this is that we have like three big systems or platforms. One of them is Copilot, so we're building Copilot in every one of our products, and so when you're interacting with Microsoft products, it's through a Copilot, which is the user interface to AI systems. Then, for people who want to extend our Copilots and build their own, we have a whole Copilot and AI stack. And then that's a new trend, which is Copilot devices, the Copilot plus PCs. One of the interesting things that happened last year is that while the first 2 years of the AI revolution were all about cloud, running these models on really large systems in the cloud that was running in parallel or on large GPUs, right now the trend is to miniaturize all this, start to have some of these chips as part of your laptop or your cell phone, and running these models locally, and I'll show you a demo of that. So the way I'm framing how you can achieve more with AI is by like this way of looking at it where first you use whatever AI systems exist. So here, for example, I'm going to talk about Copilot, but there are many others from other companies. So you adopt AI tools, you play with them, you experiment. It's a process, so it takes some time and you need to experiment with things and see what works in your workflow, tweak things. It doesn't work right the first time, and it's really an experimentation period. And to me, it looks like a lot like the previous revolutions, like the web. When the web happened, there was a lot of experimentation about how do I move from these client-server applications that I'm using on my desktop to building web applications or to using web applications for my workflows. And it took a while for people to realize what the ideal model would be. Then the next level is if the systems don't work out of the box for your need, whether business need or personal, then you can extend them. Many of them have extensibility hooks. I'll talk a little bit about the ones that we have in the Microsoft Copilots, but most systems have APIs and ways that you can extend them. And then if that doesn't work, if you're a developer, then you can build your own. And I'll show you that on the Microsoft side, actually, if you're not a developer, you can build your own as well. We have something called Microsoft Copilot Studio that helps you build your own agents, even if you're not a developer. So let's talk about the adoption aspect first, adopting AI. So one of the articles I found really interesting is this work trend annual report that Microsoft and LinkedIn created that talks about how are people adopting AI at work. And there's what struck me in there that there's this notion of a new kind of user that's emerging that's called the AI power user. And I think one of the things you can do if you're looking at AI and thinking how can I achieve more with this is to become one of these AI power users. What the survey found is that people who are adopting AI and are experimenting with it, and there's lots of experimentation, people are trying prompts every day, they look at the list of things that they're doing every day and they're trying different AI tools. And experimenting. We're really in an experimenting phase, and there's lots of sharing as well. So you can go to user groups, share with others, share with your colleagues what you're learning in there. And I think Donna Sarkar was here last year, and she was talking about that. And we're still very much in that phase where there's lots of discovery. What the report showed is that people who are doing that, adopting these AI systems, they tend to have more satisfaction in their job, they tend to get more things done, and so in that phase of adoption, this is really something that you can try very easily. You adopt some of these, you experiment, you see what works and what doesn't, and what kind of tasks and use cases will be well covered with AI. And this will touch every area of the business, so every employee, every functional and business roles. In security and IT professionals, this is a big thing, and for developers and data professionals, this is the first application that we created actually with GitHub Copilot. So there's a lot there. So at Microsoft, the way we build that is through the creation of copilots. We have one that's called Microsoft Copilot that's tied to M365. In there you have a business chat. You have a new type of artifacts that are emerging, something called Copilot pages, where you start your chat, you do some research, and then you can push that research to an artifact called a page, where agents and humans are going to interact together. It's like a shared document where AI is adding things on the go. There's Microsoft 365 apps, so maybe some of you have created team bots. You can recycle them and adopt AI with them. And then there's Microsoft Copilot Studio, and the vision from Microsoft there is that there will be many copilots and agents, potentially millions, and you can think about them not as like a big system that is very complicated to create, but more like an Excel spreadsheet. You're going to tie an AI, an LLM model to some SharePoint data and some other business data that's coming from Dynamics or other systems, and then have it automate a process that you're building in the enterprise. And so Copilot Studio is a low-code tool that's from the Power Platform team that really helps you build these on the fly in a very easy way. And there are many other tools. So this is an example of what it looks like in the work stream, the daily work stream of someone who's working in a product development team. So you start with Copilot in Teams. I'm using that a lot for example, looking at summaries of meetings. Or while in a meeting, if I'm talking to someone else, while someone else is talking, I can ask the Copilot, what did they just talk about? Or for meetings that you skip, you can ask it, hey, did they talk about my group in there? Do I need to do some things? Then you go to Outlook, and it can help you write your emails. You go back to Teams, and then in Word, it can help you write your documents. Then you can do a chat in Copilot, and then go back to Word. So it's all integrated into many of the Microsoft apps, and this is an example of the type of things here. A very quick example where you're planning a trip to LA. You're creating, out of this chat, you're creating a page that you share with other people, and then these people and the AI are going to collaborate on this shared document. So to me, pages is kind of a new type of artifacts that are emerging in this age of AI, where humans and agents are interacting together. And so it should make it, and to me, this is really one of the areas where we need to learn how to interact with these agents. This is really a new skill to develop. There's a really interesting paper from the BCG group and Harvard Business Review that I found super interesting, called The Jagged Frontier, where they studied several consultants. They gave them different tasks, and one group had AI, the other group didn't have. And they studied how it works for different type of jobs and how do people adapt to it. I found that paper super interesting. Ethan Mollick is part of the authors, but there's a really big list of authors. The two things that struck me in that paper, and I really recommend reading it, is that they call that frontier between what AI system can do and what your tasks are about. So AI systems can do a few things really well, but then not everything. And so that's what they call this jagged frontier, where there are some tasks where they're really good at, and some tasks where they're really not good at all. And for the specific work items that you want to do, you need to determine where the frontier is. And these models are constantly evolving, so that frontier is moving. But when you want to apply it today, you need to determine how are the models doing for the work that I'm doing. So I'll give you an example for coding. For example, it's pretty good today if you're using something like GitHub Copilot. But if you want to do math or calculation, many of these models are not very good at that. And there's a lot of different tasks in the middle. The second diagram that you see on the right there, this one I found super interesting. They determine that for beginners in a specific job type, the AI helped them gain much more in terms of productivity gains and achieving more than for experts. So what that means is that whether you're an expert or a beginner, you're going to improve from using AI. But if you're a beginner, you're going to improve much more. And so one of the corollaries there is that it's going to reduce the gap between experts and beginners in different tasks. So that's something good to think about if you're managing a company or if you're training people in your team about what does this mean for your business. The other thing that was in that paper that I found super interesting is this notion of how are you adopting it. And people have kind of two big approaches that they call centaurs and cyborgs. The centaurs, it's this creature that has the body of a horse and then a human top. And so the centaurs are typically pushing down a bunch of tasks to the AI, so that's the horse part. And then for the top-level task, they're doing it themselves in a traditional way without using AI. The other type of adoption is cyborgs. And cyborgs are more about, I'm using AI for every aspect of my work, and I will interact with it and ask it, reason with it, using AI to reason together. I find myself more attracted towards the cyborg model, but I guess it's a personal preference, and also depending on the type of task that you're doing, you may want to do one or the other. There are two books I would recommend. So AI is adopted into many different industries and processes. The one from Ethan Mollick called Co-Intelligence, where he talks about how to work with these agents. And Ethan is one of the one of the authors of the paper I mentioned before, the BCG one. I found his book really good. It's a kind of good primer on how to use these AI systems. I highly recommend it. I really found it very enjoyable, pretty grounded into experiment. He's experimenting himself with all this, and he's talking to lots of people in different industries who are adopting it. Now, there's a specific segment or a specific sector where AI will have potentially huge consequences, which is training and learning and education. And so Salman Khan, who created the Khan Academy, Khan Academy partnered with Microsoft. We gave them early access to GPT-4 for them to build their AI system for Khan Academy. He has a whole book about what are the consequences in education. And this one is really fascinating. He's talking about things where you could have students talk to agents that represent like Plato or Aristotle. If they have to do a dissertation, they can talk to the actual representation of these people, agents that have access to all their books and they can interact with. To me, it's like a really different take on education. And he has the professors at the center of this. And I know in education it's really a challenge, adoption of these AI tools. His book is very hopeful in this area. Now, if you're creating a startup or if you're working in a startup, there's another angle which is, hey, which opportunities are there to create new products with these AI systems? I found this talk from Martin Casado, who's one of the partners at Andreessen Horowitz. It's from like 2 weeks ago. He gave this interview where he talks about what works today, what do they see in the VC world about big areas where people are creating companies. Creative composition is one, like anything that has to create images, create text, or create videos. Companionship, like these virtual companions, that I wouldn't have guessed that people would be interested in that, but it seems to be a valid use case there. And then coding, and coding for sure, it's the first one that came out, and there are lots of companies in that space, including Microsoft. Now, talking about AI for coding, this is really a use case that is very popular. And so there are more developers using AI for coding than developers building AI systems themselves or working with models. And so GitHub Copilot was the first Copilot that was built by Microsoft with a GPT model. I've been using it for a few years now, and it's, I mean, how many people here have used GitHub Copilot? Okay, a good number. So I hope you're happy with it. It's not perfect. There's always improvement to be done with it. But overall, it generates lots of code. It helps people be faster. And we had a discussion at the speaker dinner yesterday about what each of us were seeing in terms of productivity improvement. The number here of 55% faster is coming from a survey that GitHub did in 2023. But there, I'll talk to you about another one. And then the big one to me is that developers feel more satisfied and more focused when they are using GitHub Copilot. So in terms of the survey, the 55% number came from that survey at the top here. That's from 2023. But there's been one that I found super interesting in communication of the ACM, called Measuring GitHub Copilot's Impact on Productivity. And what they found there is that the acceptance of completion is a good measurement about whether it will impact productivity or not. So and there's lots of details in that survey. It's much more nuanced. And the conclusion of the survey is that it's not only the like pressing tab and getting code generated that is important. It's more like using Copilot as a dialogue and interacting with it. And so I can, actually, no, I'll do a demo of Copilot a bit later. So the other thing is, in terms of learning, one of the important things is to learn to prompt. So there are lots of advice on the Microsoft Learn website about how to learn how to prompt, and it's an important skill to learn. It's not very complicated, but these systems are not magic, and you need to learn how to prompt them. So first you need to have a specific goal, you need to give them some context, you need to tell them what type of source of data should they look at, and then you need to tell them your expectations in terms of the output format or things like that. And these systems evolve constantly. For example, the most recent ones, large language models, they have been trained to generate structured output with JSON or things like that. So in terms of when you're building these systems, it's really important to have structured output as opposed to just text. And then in terms of prompting, I really like this article from the Microsoft Research called The Power of Prompting. It's a use case where they worked with people in the medical field and to work with different approaches to prompting, from like the simple prompt to start to talk to model of experts and have a model supervise other models. And there's lots of Actually, the LLM themselves can help you do better prompts and create better prompts. So this is a really interesting survey and worth taking a look at, especially if you're building this type of systems. So extending AI. So these systems, you adopt a copilot. Actually, maybe I'll do a quick demo first of what does it mean to adopt a copilot. So I'll just go into yeah. I'll just go into Copilot. So that's the paper I was recommending. So this is Microsoft Copilot. You have the web version. So the web version is going to look on, it's using the Bing index behind the scenes. I'm just going to like go look around it. So here I know that my colleague Mike has a talk later at the ISTA conference, and it's about the fifth element, but what is this talk about? So then I can ask that type of question, and what happens behind the scenes is that it's doing a retrieval augmented generation with the Bing search index. It's getting a few documents from Bing based on what I have in the prompt in there, fits that into the prompt in addition to my prompt, and then it's asking the model to tell me something about it. And hopefully it will, well, it will generate something. That's a real live demo. Let me try to maybe reload it. Okay, so I'll try again. Okay. Okay, so his talk is about Azure Secure DevOps. So if you're interested in that, it's a talk that's later today. But now that's so that's a simple thing that I can ask it. But then I can go into the work copilot, and in there I have some specifications. For example, Visual Creator that is using DALL-E to generate images. So here I'm asking it to generate an image representing the audience of developers and decision maker at the ISTA conference. And it's a beautiful morning. Many in the audience are drinking coffee. I don't know if any of you are drinking coffee. I'll take a picture of all of you, and then I'll compare it with what it produces. So what do we have in there? Ooh, okay. Well, that's okay. There's still some work to do here. So this is where, like, you need to, you can be much more specific in your prompting in there. So that's another example. But then one of the beautiful things about the work copilot is that it has access to all my emails, my calendars, and so I can ask it things like, what did I discuss with Rado for the topics of the ISTA keynote? And so Copilot knows who I am. It has access to my email. I should select a new chat. Oh yeah, it's not in Visual Creator. I should do that in the main Copilot, I guess. Aha, so maybe I'll just go there. Yeah, and I'll do that here. And so here, what it's going to do is that it's going to look in my Outlook email, in my calendars, and it's going to, yeah, so we talked about the presentation, this keynote, and I had several email exchanges about that. So I can ask questions about what's in my inbox to it. But then I can also, like, this is a GitHub Copilot. So here I'm in VS Code. It's the insider version of it. I have GitHub Copilot in there, and I can ask it questions like, there's an Azure Assistant in there. I can ask the Azure Assistant, do I have an Azure OpenAI service deployed in my tenant? And so here it's going to talk to Azure. It's doing RAG with the Azure service. And then it's going to look at my tenant and see if I have any OpenAI thing deployed. And then when I'm coding, here's an example of, like I have a JSON file. This is actually an extension. I gave a talk last week at a conference for how to extend Copilots. This is what is called a declarative extension, and there's a JSON file in there. And I'm just going to ask it, what is this JSON for? Well, what is this? So I selected some code. What is this section of the JSON for? Let's say I don't know how to, I don't know how to create an extension. I haven't read the docs. I'm just going to ask GitHub Copilot. So here you can see that it's telling me, oh, this section, it's for a set of conversation starters. It has a title and text. So it explains to me things about the format of the file itself. And I find myself more often like not going back to documentation, but just asking questions about the code in there, explaining what that code does. One of the things that is super useful there is if you're coding in a language that you don't use very often. So for example, I'm a Java and Python developer, but I don't do much Rust. Now I can review some Rust code and try to understand what it's doing. One thing I wanted to show you is we announced something really cool at GitHub Universe last week, which is here you see this little combo. It says GPT-4o. So GitHub Copilot by default can use the GPT-4 model. What we announced last week is that now you can switch from GPT-4o to Cloud Sonnet, for example. So you can do Claude, and soon I think Gemini will be there. So there I'm going to ask this, I'm going to ask the same question to my declarative agent. What is this section of the JSON file do? And what you will see, so this time it's doing the same thing, but it's going to ask the question to Claude instead of GPT-4o, and there you see that it's actually a little bit more detailed. So it's that model. It's explaining that it's an array of conversation starters. It's a little bit more structured, and then it shows me some implementation details and some usage flow. So the models are different, and now you have a choice to pick a different model in there. So there's lots of progress and changes in GitHub Copilot all the time there. So here I showed you a few examples of how to, what does it mean to adopt a Copilot. Now let's talk about extending it, which is when you, so when you adopt a Copilot, you try it out and all that, and then you prompt it, and sometimes the system doesn't provide everything that you need. You want to like add some specific data connections, you'd want it to do some more automation. For that, there's a way to extend these copilots, and so the second way is to start extending them. So with M365 Copilot and Copilot Studio, you can extend them if you're not a developer. If you're a developer, the code I showed you before, that's an example of a Copilot extension that you can build in code. So at Microsoft, we have things like Microsoft Fabric, where you can connect all your data to the copilots. You have Microsoft Dataverse, which is like all the Dynamics products and the data layer in Dynamics. Microsoft Graph is all your data from Office, M365, Teams, Outlook, and all that. And then you have data connectors to external systems like SAP, where many enterprises have a lot of their business data. So all that, you can connect it through Copilot Studio to create your own agents. And so this is an example of what creating an agent looks like. So here I can prompt it. So I create an agent through prompting the system. So I can say, hey, I want to create an agent that's based on some SharePoint data. So the grounding data is going to be data from SharePoint. It creates an agent for me, then I can edit the different triggers. I can add some additional data sources like Dynamics. This is where I could connect it to SAP or something like that. I can upload some additional data, and that field service agent, then I can deploy it to Copilot. And that means any user of Copilot within my company, with the rights that they have, so they are logged in, so I know who they are, and so the security is going to go all along through all of the systems, and they're going to be able to interact with it. I'm going to show you an actual one that I created for my team to make that pretty specific. So recently, sorry. Oh, sorry. I'll just... I'll just exit there. I'll go back to the browser. And here, so my team, developer relations, we're part of a team called Ecosystems. And recently, surprisingly, at Microsoft, there are many reorgs. And so recently, we've been reorged under a different organization. And the question was, we were like probably 7 or 8 teams. We had an offsite, and we realized we don't know what the others are working on, what their strategy is, or etc. And what I suggested is, in order to make things simpler, we all have our plans, like our strategy, the team structure, all in Word documents on a SharePoint site. I'm going to create an agent that I call the Axe Team Agent. So Azure Experience and Ecosystem is the team that we're part of. And I created this custom agent. It took me probably a good part of 10 minutes, just putting a name, putting these different prompts, like what type of question can this agent answer, connecting it to the SharePoint site for my team and for the other teams. And then I can ask it questions like, for example, my team is developer relations, so someone who doesn't know my team, they can ask things like, what is the developer relations team mission? And for that, it's going to do RAG, retrieval augmented generation, with the SharePoint site where the strategy document, where my team's mission is defined, and it tells me that the mission is to help tech communities achieve more with AI, which is what I'm doing today, and that we partner with several other teams. But then I can be more specific, which is my team, developer relations, we're organized by tech communities. Some of us focus on Java, Python, AI, etc. So I was wondering, if I'm a product manager and I don't know your team, who should I reach out to with questions related to the Java strategy for the advocacy team? And so there's a guy named Julien Dubois in my team. He's based in Paris. He manages the Java advocacy team. And now I can ask questions like that, and if I don't know anything about developer relations and I don't know who to search for in the org chart, now I can ask question, and it's a real life demo because it's barfing on it. But what it's going to do is it's going to look in there, and yeah, he found Julien Dubois, and I could ask more questions like that. So that's kind of the extend. So once you have adopted, you can extend them, add your own data. And sorry, I just wanted to say, so these are numbers from inside of Microsoft, where like we had some really good results in different groups with this. So Copilot Studio, take a look at it, check it out. It's a good way of doing that if you're not a developer, building these agents. But then if you're a developer, I gave a whole talk last week on that. You can use Visual Studio Code and the type of code I showed you before, the JSON file, with what we call declarative agents. So it's a very simple way of doing it. If you have more complex needs, you can build your own, like in Python or Java or whatever language, and there you can pick your own models and things like that. Then the last thing is, if none of these approaches work, then you want to build your own agents. So how do you do that? The way LLMs work is it's like a language calculator. You have some natural language input, so it's a set of text. It's reduced into a set of tokens, which are bits of words. that are translated into numbers. There's a big matrix calculation that happens in the GPU. And then the model spits out a series of next token potential with a probability distribution, and it just generates the next token. That's all that a model does, large language models. The way we make them work to do interesting things and give you interesting results is with an architecture called retrieval augmented generation, where the user asks a question, you prefix that question with a system prompt, like telling the system a bunch of things, and then you query your data, typically using either a vector database or hybrid search, to find some data that is relevant to this. And this is where you need to do like a role-based access control and be secure about this. And then you add the results to your prompt, and then you ask the model for next token, and it's going to generate something that is interesting in this area. In Azure, we have a whole stack to help you build that. We call that the Copilot and AI stack. That stack is composed of a bunch of components. So there's an AI orchestration and toolchain. There's your data layer. There are foundation models, and a set of AI infrastructure. That AI platform is also a cloud platform. So these apps are just regular apps. So you still need a runtime, whether it's in containers or VMs. You need to have a whole set of AI-specific services to build these apps, for building a responsible AI layer, for evaluating the models, evaluating the quality of the results, and things like that. And then you need developer tools. So on our side, it's like GitHub and Visual Studio Code, and then Copilot Studio if you're a low-code developer or if you're not a developer. If you're a developer, there's a new emerging profession that's emerging called AI engineers. I highly recommend this blog post. There's a whole community around that. And the notion is that in the same way that the full stack engineer emerged when the web era started, engineers who could do the full front end and back end of your application, AI engineers in the same way like develop a whole set of practices and learnings around not only how to tune model and things like that, but how to use these models using APIs, how to do the vector search, how to use orchestration layers for this and measure quality of the results. Another trend that's super interesting is small language models. Highly recommend the Textbooks Are All You Need article by Sébastien Boubek. He's the person, the team at Microsoft who created the Phi model. And the notion was the GPT models are trained on the whole internet. There's a whole bunch of like really bad stuff in there, things that are not accurate, and that's why models sometimes like give you results that are really like not very smart or even false. The notion here was, let's try to train models on just textbooks and generated content from the textbooks. And so the notion there is to create smaller models based on a smaller set of data of higher quality. And the results from the benchmarks are really very good there. So these models are smaller, they can run on your laptop. Soon they can run on your phone as well, and they have a really high quality, and they can be used in lots of different contexts. The fact of having smaller models with less parameters also allows you to have a faster response time, generate less carbon less carbon emission when you're running the model inference themselves. So when you're building these apps, initially you can make them run with one of the big models. But at some point, it's worth tuning and trying with the smaller models to see if that works as an approach. Another trend that's super interesting is running these models locally. There are tools like Ollama or AI Toolkit for VS Code or LM Studio that enables you to run these models locally. I'm just going to show you that. I installed it earlier. It's a new extension in VS Code that's called AI Toolkit, where like you can get all the models that are available in the GitHub catalog, plus some local ones. And here's an example Here, I downloaded the Llama 3.2 3 billion parameters working on CPU. And so I downloaded the weights of the model, and it's running locally on my machine. So I can ask it questions like how do I build an application using Llama model in that playground. And here it's running, it's doing the inference locally on my machine. It's generating, it's a little bit slow because it's using the CPU. But that's a new trend where now you can run many of these models on your laptop, and I think soon many of these are going to run on your cell phone. So that's for running models locally, and I'm out of time. I'm nearly done. Orchestration. So all of these, when you build these systems, you need to have you need to orchestrate several models. Having a model like drive the whole interaction. There are many frameworks for that. Semantic kernel is in .NET, AutoGen is in Python, and LangChain is in several languages. I know my team contributes to many of them. And then trustworthy AI. One aspect of all this is that there are lots of risks associated to AI, so you want to have a trustworthy AI approach to all this. At Microsoft, the way we translate that is that it needs to be secure. So we have something called the Secure Future Initiative to secure all these systems. You want to enforce privacy principles for all this data when you're building these AI systems. You want to make sure your users are okay with sharing their data and that people have only access to what is available to them. And then there are a set of responsible AI principles around privacy and transparency and safety and groundedness. So we're doing a bunch of things at Microsoft around these aspects, and you can find a lot on the Microsoft Learn website. So that's kind of what I wanted to share with you. You can learn more on Microsoft Learn. We have this page called learn.microsoft.com/copilot. In there, we're constantly updating content about how you can adopt, extend, and build your own copilots. And then learn.microsoft.com/AI for when you're building your own AI systems. How will you leverage AI? I'm kind of looking forward to see all the cool applications that you're going to create with all of this. Thank you.